Hi, good afternoon. Hi. Oh, that was a very sad, sleepy hi. Try it again. Good afternoon. That was a little better. Thank you. All right, so welcome back. I hope that y'all remembered your glue. So we're going to use some glue today. I've got some writing utensils, different colored pens, some highlighters. All right, we've got our notes to cut and glue, so please make sure that you've taken a moment and cut everything out individually. Do you like my magic trick? I just waved my scissors and poof, it all fell apart. The magic of cutting it beforehand. So you have two titles. You can cut those out if you'd like. And then we have three different pieces. We have a little paragraph that says sports. Yes, I know there's a little hand in the middle of that paragraph. This is what happens when I don't move my cursor before I take a screenshot. Then we have this one, the little table, so that's going to go next. And then the very last thing that we're going to glue is the long paragraph that starts in a triangle. So that is the order we'll be pasting stuff in today. Please make sure that you have gotten a copy of today's assignment, which looks like this, C7L1, titled Ratios and Proportions. And I'd like you to take some time between now and maybe a minute or two after lecture to just look this page over and try to find questions or words that when you look at make no sense. So that way you can tell them to me after lecture and I can make sure I include those specific words or problems on my walkthrough video, which I will cut later this afternoon. So it's available for you over the 3 days that we won't have class for testing, Wednesday, Thursday, Friday. Please remember that this assignment is double-sided, so front and back. Be sure that you're looking front and back for words or questions or problems that you would like to see in your walkthrough. I'm sorry? Today is the 11th of January. I'm going to update my table of contents really quick. I'm going to leave a line for my C4, L4, and 5. And one of my titles today is going to get glued in. There it is. Here was last week's lecture. And we are going to leave a blank page for KWL. Reminder, since it's been so long since we worked together, KWL stands for something I knew, which is when you get the assignment back, it was one of the questions that was the easiest for you to accomplish. You'd like an example of a W, a question that you worked really hard on, but you still got. And L, a question that you learned the most from, whether it was in doing it and you got it right eventually, or working with classmates, or you got it wrong the first time, you did it in corrections with classmates, or you came in for tutoring, that would count as your L. You want to put examples of those here, so that way, when you're studying, you have 3 good examples that you can look at. Today's notes then will start on the very next page. So go ahead and take a moment now and get your notebook updated. What? Take a moment and get this page updated for notes today. Oops. I cannot draw straight lines. As we're writing today's objectives, let's take a moment and read through them. So the first big vocabulary word that we run into in the objective is the word ratio. Do y'all remember? What is it? Like 1 to 5? Like one side is a fact and another side is like a question? Okay, I can see that. What else do you think of when you think of the word ratio? Later, ladies. Like a fraction? All right. One cow to 5 boys? Okay. I'm not going to ask for details on that, but okay. The difference between 2 things. All right. All of these items, including the boys to cows, as confusing as that might seem, definitely sound like you're on the right track for what a ratio is. So just be listening for that word ratio in the discussion of today's lecture in what we're going to have it mean here. The next big word is proportion. So when you hear that word, what do you think of?
Oh, that's fact question.
That's fact question. Okay.
Amounts, different amounts.
Different amounts. All right. Any other thoughts on the word proportion? Like an if-then? All right. Okay, so again, be listening for that word proportion as we go along in today's lecture, just so that we can make sure that it's matching up with what you already have in your heads. Let's see. Then the next one we come across is cross-multiply. What's that? Yeah, it's where you go like this and you make an X. She did this with her fingers. And you multiply and do stuff. All right? What about extended ratio? Can we nod? Is that what you said? Can we not? Oh, I heard, I don't know. Okay. So I heard, can we not? I was like, can we not do an extended ratio? All right, so we're not sure. So that's the big one for you to be listening out for during today's lecture and making sure that we get a good idea of what an extended ratio is and answer that kind of burning question in your head. So let's go ahead and get started with the first topic of today, the ratio. A ratio is a comparison of two quantities. What's a quantity? A number, a value? Yeah, like an amount of something. Yeah, the value, the number of cows.
Or you have two possibilities?
Or two possibilities, yeah. But in particular, this comparison is going to use the numeric operation of division. Quantities. Yeah, I'll zoom it in a little bit.
I don't know, when you take off the side.
When I take off, oh yes. That? Yeah. Comparison of two quantities, specifically using division to make that happen. So there's a couple ways that you can write this. The first way to write this comparison is this way. And this is read A to B, like 1 boy to 4 cows. This was your example from earlier. Or you can write it this way, as a fraction, at which point it is correctly said as A divided by B. I will still shortcut it and say A over B. I'm not being technically correct. But in either case, because this comparison is using division, it is super duper important that B, the value in B, never be 0. Because it's all fun and games until someone divides by 0. Don't do it. You'll break algebra. When you get a chance, glue in your first example, the paragraph, followed by the table of information. We're going to fix the fact that I have a little hand here because I clearly need to learn how to move the cursor before I take screenshots. And someone with a big, big voice, do you mind please reading our example paragraph?
Hi.
Someone with a big voice, can you read it for us?
I'll read it.
Okay.
Sports. A baseball player's batting average is the ratio of the number of base hits to the number of at-bats, not including walks. The table at the right shows Ian Kindler's career batting stats with the Texas Rangers. What is his batting average?
Awesome. So baseball batting average is the ratio. So we're already starting to think here that whatever his batting average is, it can be written as the number of base hits to the number of at-bats. But let's get some context on this, because when I first read this question and I was pulling it for you guys, I went, what's a base hit? And so I called my brother because he loves baseball. And my brother went, really? Come on. I was like, I don't know what this is. So do y'all know what a base hit is? Base hits to at bats. Yeah, when you hit the ball and you get onto a base, first base, second base, third base, home run. Yeah, you get to stand on one of the little white pillows in the middle of the field and you wait for the next person to hit the ball so that you can go to the next white pillow. That's how my brother had to explain it to me because I wasn't getting it. I'm special. And at bats is I get to stand there and swing the stick and try to actually hit the ball. Okay? So that's his batting average. It doesn't look helpful. It's hard to tell what we're supposed to do with these numbers. So we're going to go ahead. Huh?
Divide.
Yeah, divide, because a ratio is division. But I'm special and I have really dumb moments. And so I have to make it like super, super simple for myself. And so now it becomes super clear to my brain. Duh, I'm supposed to be dividing here. The batting average is the number of base hits divided by the number of times he was actually up there trying to hit the ball. All right, so let's do our substitution then. So batting average, the number of base hits. Now there's a lot of information on the number of times he actually got on base with a hit. But since we want his career batting average, which value should I use?
8 years old.
Yeah, the total, where they added it up for us already. So the number of base hits, 1,145. The number of times he went up there and actually gave it a try, 4,201. And now you guys get to pull out your pocket calculators. You know the thing that occasionally tells you that someone has sent you a really cool Snapchat? Yeah, that thing. Ignore that notification. Go to the calculator app and tell me to 3 decimal places what his batting average is. I know it's going to start with a 0.
4 decimal places?
To 3. 2, 7.
2, 7, 2.
Since we're rounding to this third one, what's the one right after it?
It's a 3. It's a 3.
So this is supposed to be a 3 because we need to round it because the next number after that 2 is a 5. Yeah. So when you're asked to 3 decimal places, make sure that you go to that third one. You look to the right of it one more to round it in case it needs it. All right, which means that he hits a little more than 25% of the time, which is pretty decent in terms of Major League Baseball. That's not bad. You know, he's going to hit it at least once. All right, need you to draw for me a pair of eyes that are looking forward into the future. Into the future. Because not only did we calculate his batting average, but in fact, the above calculation represents a way to find the slope of a very special linear function. Please remember that a function is some sort of equation that relates an x coordinate to a y coordinate on a graph, and that when you draw the picture of that relationship, linear means that it becomes a straight line. And this special linear function is called a direct variation. Now, we're not going to spend any time in this course studying direct variations. In fact, beyond this mention, we're not really going to deal with it. But I wanted to put it here as a seed for you in the back of your head for when you hit Algebra 2, they're going to spend an entire unit or entire section. Oh.
What exactly is it?
A direct variation? It's a setup that looks like this. So it's a special linear function. And they'll explain it more when you hit Algebra 2. But what we did, this ratio thing, it becomes the slope of it. Okay? I'm out of room on this page. If you are too, go ahead and follow me to the next page. If you have at least, I'd say 5 or 6 lines, you should be able to get in the next definition and example, which will be the last gluing that you're doing for the day. So here I go, going to switch pages in about 10 seconds. 5, 4, 3, 2, 1. All right. Don't worry if you didn't get a chance to get all of that down. My notebooks are still available for photo opportunities. Just make sure that you mention the notebook when you tweet it at him, okay? My notebooks aren't snobby. They like selfies. The next concept to talk about is the extended ratio. It's related to the regular ratio in that it is a comparison, but instead of just 2 quantities, we now have 3 or more quantities that we are comparing. Just like the regular ratio, it can be written this way: A to B to C, which means you end up with 3 different ratios. You end up with A to B, B to C, and A to C. This does not mean that all of those ratios are equal. This just means that this is the relationship you can put them in. Please glue in your final example. And mark it that it is an example. It says that in some triangle, the ratio of the measures of the sides is 2 to 2 to 3. And that the perimeter is 392 inches. This doesn't mean that 2 plus 2 plus 3 is 392, but 2 times some number plus 2 times some other number plus 3 times that same number is going to give me that 392. This starts to feel a little bit like those dilations that we did, remember? Where we had the scale factor? This idea allows us to write an equation so that then we can solve for that unknown value, that scale factor, x, in order to discover what the length of the longest side is. Recall that the word perimeter means to add up all the sides. All right, I've got my equation. What do I do? Add them all. 2x plus 2x's
4
plus 3x's.
7x.
Lovely. Now what?
Divide by 7 to get x alone.
Beautiful. Divide by 7 to get x alone. I love that full explanation. Thank you. All right, use your pocket calculators. Ignore the Twitter update. And tell me what 392 divided by 7 is. 70 something?
56.
56?
3.
Wait,
56.
56. We're done, right?
No.
What am I missing?
You gotta find 3x.
I've got to find the length of the longest side, which means I've got to figure out which one it is out of these 3. The 3x, so I'm going to take this value, multiply it by 3, and it'll give me my answer, which was sitting there the whole time. 168. Feeling all right? This is okay? All right. We've officially hit the halfway point. Don't worry, it'll go much faster. Let's go ahead and move on to the next topic. The next topic is the proportion. I think in the setup when we were doing the recall, reading through the objective today, we were like, proportion has something to do with fractions? Or an if-then? Okay. Here's what I've got as a definition for proportion. A proportion is an equation that states that two ratios are equal to each other. So you're going to have something that looks a little bit like this. So one fraction equals one fraction. Let's do some real quick anatomy because we're going to need these proportion body parts here in a little bit. These two values here are called the extremes. And these two body parts are called the means. We need this anatomy to give us the very next concept. I'm sorry? Ooh. She's already feeling it. Instead of cross multiply, though, we're going to use the word cross product. But you're going to see real quickly it's going to mean almost exactly the same thing. The cross product is the product of the extremes and the product of the means. This definition sets us up for the very last item. The very last item is a property that is called the cross product property. The cross product property says this. The cross product of a proportion are equal. In other words, if I have some equation that is a proportion and looks like this, then the cross product, which means the product of the extremes, is equal to the product of the means. Does this look familiar? As what? What do y'all know this process as? Yeah, y'all know this as cross multiplication. This is the terminology that they have given you to mean this. And so when you're talking with your colleagues and your classmates and you're saying, hey, we need to do some cross multiplication, that's fine. Y'all know exactly what you're talking about. However, if you were writing a proof, and in the proof you need to do cross multiplication, you cannot call it cross multiplication because its proper name is the cross product property. Okay? So in our conversations, hey, I'm going to cross multiply. Everyone knows you're talking about thumbs up, but when you go to write it in a proof and you need to give a reason, you have to give it its formal name, the cross product property. Any general questions about anything covered today?
Oh, yeah.
Yeah. Thank you.